Ladies and gentlemen, a pleasant good evening and welcome to our Industry Expert webinar. It is my great pleasure to have you with us this evening, and I sincerely appreciate you taking the time to join us. We have an exciting session planned filled with insightful discussions and valuable knowledge sharing. As we gather virtually from various locations, I am reminded of the power of the technology in bringing us together. Our theme tonight resonates with the ever-evolving digital landscape, and the insights shared today will undoubtedly be both timely and impactful. Our esteemed speakers have prepared to share their expertise and agentic workflow and generative AI, a subject that is increasingly relevant in today's world. We hope this session will inspire new ideas, broaden your understanding, and encourage meaningful dialogue. Before starting our session, I would like to request Mrs. Kardeepa Ma'am, Assistant Professor of CSE Department, to give a brief introduction about esteemed industry expert Dr. Anit Sharma Sir, AI Scientist, Manager, EY Private Limited, India. Ma'am, please.
Good evening, everyone. On behalf of the CARE ACM student chapter, it is my pleasure to welcome you all for Agentic Workflow and Generative AI webinar. We are thrilled to have you join us today for what promises to be an exciting and enriching experience. Our event features an impressive lineup of eminent speaker Dr. Anil Sharma, AI Scientist Manager from EI Private Limited. He possesses over 12 years of experience in the fields of artificial intelligence and machine learning, during which he has contributed significantly to the academic community through numerous publications in esteemed journals and conferences. His research primarily focuses on machine learning and reinforcement learning methodologies. Dr. Sharma and his PhD from IIIT Delhi, specializing in reinforcement learning. Prior to that, he completed his MTech from IIIT Delhi, concentrating on sound event detection and analysis. Notably, he served in Sony AI Lab in Tokyo, Japan, where he worked on RL algorithms with applications in kitchen robots. He currently serves as a scientific manager at EY India, where he applies his expertise in reinforcement learning to the domain of finance. Throughout his academic journey, Dr. Sharma has authored 7 first author publications in renowned journals such as IEEE ACM Transactions on audio, speech, and language processing, as well as 4 A-star conferences and workshops, including ICAPS, IGCAI, and ICML, among others. In recognition of his contributions, Dr. Sharma has received numerous awards and accolades, including travel grants from prestigious conferences such as AI ACML in 2018, IJCAI in 2019, and IARCS in 2019, as well as recognition from industry leaders such as Microsoft in 2018 and Google in 2019. Notably, he was awarded the first prize in the elevator pitch category at the Research Showcase 2015 held at IIIT Delhi. Furthermore, Dr. Sharma has demonstrated his academic process by achieving a remarkable score in the National Eligibility Test conducted by the University Grants Commission of the Government of India, placing in the 99.77th percentile. I welcome you, sir.
Hello. Can you hear me?
Sir,
Good
sir,
evening,
just a
sir.
second. Sir, just a second, sir. Our team member has some speech to convey.
Sure.
Before start, a good teacher can inspire A good teacher can inspire hope, ignite the imagination, and instill a love of learning. A warm welcome to Dr. P. Deeplakshmi Ma'am, our esteemed Dean of School of Computing, Director Accreditation and Ranking. She is not only our academic leader but also a mentor who tirelessly works to ignite the imaginations of our students and chapters. I request Dean Ma'am to deliver the presidential address.
Good evening to one and all. Can anyone please confirm, am I audible to all of you?
Yes, ma'am.
Yes, ma'am.
Yeah. Thank you so much. Good evening to all. I'm very happy to see that around 60 members have joined for this webinar. Welcome to Dr. Ajay Sharma from EY Private Limited for delivering the today's session on generative AI. We are conducting different kind of lectures or talk series to our students. Already we have ACM Eminent Speaker Program, Distinguished Speaker Program. In addition to that, we also conduct industry expert talk, alumni expert talk, and international expert talk. On these categories also, we are organizing the variety of talks with an aim of giving the industrial knowledge to our students. In addition to what they are studying in the academic curriculum, what is going on in the current industry, that is very, very important to know in this digital world. We know that technology is changing very, very fast, and it is the responsibility of the students to know well in advance about all these areas, the different technologies followed in the IT industry, and in addition to that, what technologies may emerge in the future, that is also necessary to know, and what kind of different applications we can do with the current technology, that is also essential. This always keeps them industry ready when they prepare themselves for the placement. So today the topic is towards the generative AI. We all know that a lot and lot of talks are actually going on. So we should get a correct industry expert who is really working in this area, who can very well convey about the technology to our students. In that way, the Kalasalingam Academy of Research and Education, the Kare ACM student chapter functioning in our university, is honored to have the great guest today to deliver the lecture. With this introduction, I leave the platform to the guest, Dr. Ajay Sharma, to convey his experience on the field generative AI to all our students. Thank you so much for the opportunity. Thank you.
Thank you, ma'am, for your unwavering dedication to our students and faculties. Your guidance and passion for education light the path for countless aspiring minds. Now I request Dr. Anish Sharma sir to take over the session ahead. Sir, please, sir.
Okay. Uh, can you guys hear me?
Yes, sir.
Yeah. Okay. Okay. Thank you, ma'am, for the nice introduction. And as the dean ma'am said, like we should explore like what is going on in the industry. So let me start sharing my screen, and I will present something which is, I think, a very hot topic in the industry and is going to be the future as what we believe in industry, and we are heavily working on it. Uh, I think you guys are going to love it. Let me just. Okay, can you see my screen?
Yes, sir.
Okay, so I welcome you all here in the presentation on agentic workflow. And we will be seeing how generative AI is revolutionizing this like agentic workflow, and how the agents are created, and like they are automating the different workflows that we see all around us. I have a few practical applications at the end of my slides. Uh, so I would request you to stay till end, and like, I'm sure you guys will enjoy the kind of applications that I will be showing. Okay, so before going with the presentation, let me introduce myself, like from my own words. I have hold expertise in reinforcement learning, and if you want to see my work profile, you can go to this link. I have listed all my work publications in that link, and I have several publications in top tier conferences and journals. Uh, cur- uh, uh, So very soon I will be joining as a chief researcher at Samsung R&D, but currently I am working as a AI scientist manager at EY India, where I'm primarily working on optimal hedging using reinforcement learning, where we are working with a few Canadian banks to hedge very risky portfolios of options structured notes. And we are also working on market surveillance using generative AI. How is it that we can like perform surveillance and like how the people are trading and all those things. Apart from it, we are also working on several agentic workflows for HR and others. Like I will be showing you a few applications. I have received several awards for my research, including from organizations like Microsoft and Google and several other prestigious organizations. I have worked on industrial robots at Sony AI in Tokyo Lab, uh, like where we actually worked on the control algorithms for the kitchen robots. How is it that we actually like do the cooking and all those things? Like so, basically, this was also entirely reinforcement learning based work. Okay, so several other awards, and we also have a large AI community in India. So I think people or the students, working professional teachers from almost all the states are like have joined our community. And if you are interested in joining this community, you can join using this link or this QR code. So basically, we are helping students, working professionals to like get started with AI and how is it that you can like actually build real world projects. So this is what we are actually helping people. A few recent success stories of our community is that a student from MSIT Delhi actually received like a good All India rank of 11 in GATE 2024. A few others actually got like good placed at several good organizations. There, a few students are also publishing papers. So one recent paper we got is in ICPR 2024. So why I'm mentioning this specifically is because this conference is going to happen in India this year. I guess in November or December. It's in Kolkata and it's a top tier conference in pattern recognition. If any faculty is there and if they want to attend it, please do attend it. It's, I think, top researchers of the field are going to come in this conference. And several other students have actually done a lot of things like so. So these were a few success stories. Now let me talk about the, the overview of the talk that we will be like exploring. So basically, I will start with the real world applications of generative AI, and I will give small overview of AI, Gen AI, and LLMs. So basically, I will try to spend as much less time as possible because like it actually requires a lot of time to understand this concept, and there will be a lot of technical details. I will try to give just an overview of these things, and then I think the last two parts, RAG and prompt engineering, is what like is disrupting the industry, and whatever we were doing using our hands or by some coding or whatever, right? So now they are going to be replaced by the agents, and these agents are actually coded using prompt engineering, and these agents are actually making agentic AI, which results in agentic workflow automation, and we will see how these agents are created and how things are actually coming up with it. Okay, so let me start with the presentation. So we know that AI is revolutionizing our world, from autonomous vehicles to robotic surgery. AI is everywhere, not only in our personal life but also in our professional life. And we are in the era of AI agents, and these agents are transforming industries. They are automating tasks and enhancing decision making across several domains. So we'll see what these agents are, how to create these agents, and what is it that we are doing in this area. Okay, so before I start with like any technical detail, let me just say like about I hope all of you actually are aware about LLMs. And let's say if I'm only giving one textual information to my LLM, or let's say VLM, visual language model, I want to actually generate a giant towering cloud in the shape of a man which looms over the earth, and the cloud man shoots lightning bolts down the earth. Okay, so what I want is I want a short video which is like which represents this description. Okay, so can we actually do it? Let's say if we human actually needs to do it, we actually need to hire an expert who is very good in video editing, video making, and then he will make it. And I'm not sure like how realistic it will make. But let's just see this video. So this is entirely made by a VLM and by only giving this prompt as the input. Okay, so if you see, right, so see the facial expression, this cloud, right, it looks like a human, and there are lightning bolts actually going down to the earth, right? So the description that we gave in the prompt was actually clearly represents in this video, and we have not done anything. This video is entirely generated by an AI model from start to the end, and there is no human intervention. There are so many other examples of this particular use case. So we'll be seeing like how is it that we can leverage this capability of LLMs, VLMs to create agents, to create agentic workflow. Okay, so if you see, right, so one potential application, if I want to talk uh, about in the real world, so let's say virtual trial rooms, right? Let's say like instead of wasting our time in trying the clothes at the showroom, how about like, there is an AI system which will actually say that how you will look like, eyes to see and to make the perception, to understand the real world in terms of the images. And then MRI scan analysis. So for example, maybe to see the MRI scans and identify if there is a tumor or something happening in the nervous system or whatever, right? So these kind of applications are seeing a heavy disruption in computer vision. Another transformation coming is in the field of NLP, where we make algorithms to make computers understand text and speech. For example, chatbots. I think if you make a call to your credit card company, right? Earlier we used to say, okay, press one, press two, and all those things, right? But now there is a real chatbot coming, and it will ask you like, what is it that you want? Like, can you please enter this and that, right? And then you are interacting in the natural language to do all the things. Another application is language translation, right? Okay, so let's say if I understand Hindi and you understand, let's say, Tamil, right? How is it that we can communicate with each other, right? So language translation is also one potential field where the heavy transformation is coming. Another is in the robotics, where we are actually making robots to perceive and take the right action. So, for example, in the robotic arms, so maybe to do the cooking, or maybe to place the object from one place to another place, automatic vacuum cleaner, right? All those things are actually coming. Planning and control, where we help in the navigation of a robot, for example, the self-driving cars, drone autopilot, humanoid robots, and all those things, right? Now, agentic workflow is actually heavily used in the industry, but there is another field which is highly like vibrant and is going to transform the industry, is the embodied AI, where we actually create the robots with the right perception capability, NLP capability, and they will actually do the like all the things like what a human do, and they actually do the manipulation in the physical world. Okay, so what are the drivers of this transformation? I believe that like one of the potential driver is the data. So like with the use of social media and easy access to web, we are generating a lot of data, and that data actually helps computers to come up like basically to help us train the algorithms which can understand the data or make patterns or identify the patterns from the data, right? So for example, with the arrival of the image in a data set, we actually transform the object what we say like object classification algorithms, right? And so this is one of the potential driver of this transformation. Another is hardware technology coming, like arrival of GPUs, TPUs actually makes us use of the hardware, and like we can actually train the algorithms in a very less time as compared to what we when we train on the CPUs. And access to the like these CPUs, TPUs through cloud paradigm also makes us like heavily use these hardwares, and we are now not like stuck because of lack of access of the hardware. We don't have to purchase, we can actually go to the like cloud. I think like many companies are providing cloud access for free, for example Google Colab. Another driver is the software technology, open source softwares that are coming right? So for example, TensorFlow, PyTorch, and like whatever we do, right? So like the code for most of the AI algorithms, AI models is open source, so we can use it, we can do more contribution to open source. So I think that is also one of the potential driver. Another, I think one of the major driver is this data in the business. When the business leaders has started to analyze that data is now core to the business strategy, so now they are spending more money into it, and then the AI researchers are coming up with the new algorithms at a very faster pace. And so for example, this is a very old survey, but there were like, so these are the top 10 Europe startups in 2022, I guess, and they were highly funded by the business. Okay, so that's why, like, we are able to create the new algorithms, and we are able to collect the data and all those things, right? So if I give you one example, this is one manufacturing plant where there are humans who are assembling different parts of a CPU. But let's say if we replace these with a robot, then one robot will do the job of 200 employees. Now you may say that, okay, so the arrival of embodied AI or agentic workflow will actually take the jobs out. This is true. I think now we are getting the news of that many people are getting laid off. It's not because the companies are not performing well, but it's because that companies want to now start with the AI. They want to hire new talent which has AI skills. So they are laying off at a very large scale. But it's not that AI is actually bad, very bad. But if you see that, so there is a product which is actually deployed. Like, so for example, there is a industrial robot which actually comes up with several sensors. It needs maintenance, it needs coding, it needs assembly and all those things. So this also actually needs like human. And this robot is not only the hardware but also the software, where we can also provide software as a service, and you can develop those kind of softwares. So with the arrival of robots, yes, old way of actually doing the jobs is actually getting laid off. But now there are new opportunities coming, and we can upskill. Since you are students, you can upskill yourself, and like you can train yourself with the skills that industry requires, so that you will not face the problems of the skill gap in the future. Okay, so there are so many services that are coming. There are so many kinds of hardware coming, embodied AI or agentic AI. So, for example, there are so many things that you can do. Like, so you can learn skills for the robot, industrial or service robots. You can see like how software as a service is actually coming, web service, web apps, or like website development is also coming. Infrastructure as a service also requires so many skills. Platform as a service is also requires so many other things, right? So there are so many things that you can actually do. AI is not bad. Yes, the AI is complementing the human performance, so things are actually happening like that. Okay, so there are the risk of using AI systems as well. So, for example, let's say if you are using chatbot for any task, there could be like a possibility that it will provide misinformation. So, who is responsible for that? It may hallucinate. It may provide some information which is factless, useless, right? So, how will you actually do all those things? And there could be several other like challenges that may come when you deploy this AI system. For example, privacy concerns can also come. Bias, like, so it can be like highly biased to one particular group. So it is also highly dangerous for the company who is deploying this app. So you also need to consider all those aspects. So let's say if you fear about losing your job because of AI, you can also start with the governance regulatory aspects, and you can help companies to actually see like how you can actually help to create chatbots which are not creating these challenges, which are not creating these risks. Okay, so this is also one upfront opportunity coming for the various like people. Okay, so this was the application. Now I will give an overview of AI and ML. I think most of you must be aware about these things, but let me give a gist of it. Let's say I think we all talk about AI, ML, deep learning, generative AI. So what all these things are? Okay, so these are not the same thing. These are the same thing sometimes, because there is a, like, so one is the other field, so one is a subfield of the other. So for example, let's say if we talk about artificial intelligence, it's the umbrella of everything, right? It contains the method that enable me to really do anything. So this field actually came into existence around 1956. There is a lot of noise coming. Okay, so there is another field which is subfield of artificial intelligence. So let's say the methods that we are creating to mimic human intelligence actually use data to come up with the patterns. Then it is called a machine learning algorithm. So for example, understanding the medical history of a patient to predict the occurrence of a customer, then this method actually is called as machine learning. So then deep learning is like actually it came into existence around 2012. It was there in 90s as well, but it was not that prominent because only a few groups were working and they were not getting that much accuracy. But with the arrival of ImageNet and GPUs, researchers actually created LXNet, and this deep learning era actually took the right birth. Okay, so and the machine learning algorithms which actually uses neural networks are called as deep learning algorithms. Okay, so now generative AI is subfield of deep learning where we are using generative models in place of the normal shallow models or the models which do classification and regression. Here we train the models which actually generate realistic and creative output to mimic human generated content. For example, GANs, language models like GPT and all those things. Okay, so this is the clear definition of all these different terminologies. So if I say about machine learning, so it contains the methods, algorithms which are used to make computers understand data without explicit programming. So let's say we give the data to a black box and we get some understanding, then this particular black box is called as a machine learning algorithm. Right? This understanding could be a classification approach, regression approach, or could be something else as well. So whatever understanding we are getting, it's actually the use of machine learning. Okay, so for example, let's say if we teach computers to understand image and video data, these are computer vision tasks, and if we make them understand text or speech data, then these are NLP tasks. Okay, so types of algorithms in machine learning is that so one is supervised learning where let's say we have the data and we actually have the annotations and we actually want to create a learning which says that what kind of data it is. So using these annotations, we actually develop an understanding that what is this? This is an apple. Okay, so they say that annotations say that these are apples. So when new data comes in, we will use our learning that we have we have arrived at by using this data. So then we will say that okay, it's an apple. Okay, so we'll use the learning. Okay, unsupervised learning, we only have the data, we don't have any annotations, we don't know what these are. So what we do is we actually use some unsupervised kind of pattern recognition. So for example, using the visual cues, we'll make different categories, right? So for example, we'll do the clustering or we'll create different clusters. Okay, so the highly red is the apple, kind of something orange is and the round in the shape is actually peach, and this is banana, which has a some round shape and yellow in color. So this is unsupervised. Third is the reinforcement learning where we don't have the data. Mostly we don't have the data. So we actually do the exploration in the real world. So for example, this is a robot which actually doesn't know what to do. So it will actually go near the fire. It will explore this particular thing. It gets heating sensation. It says that, okay, next time I should avoid it. Okay. So reinforcement learning actually is mostly the hit and trial or exploration based algorithms where an agent or the robot actually develops understanding by exploring the environment. Okay, so if the data is also available, then these are actually called as demonstrations, and the learning can also be from that data. Okay, so now let's just directly go to the generative AI. I will not spend much time into the technical parts. I will only say about what is agentic AI and how is it that you can work. I think this field is very simple. You just need to see how you can actually use the tools, the right tools that are available. Okay, so let me jump into that. So basically, generative AI includes models that can generate new content such as images, text, music, etc. The key applications are in the art and design. So, for example, generating artwork, music, or design elements. In natural language processing, we can craft human-like text for chatbots, translation, etc. And media and entertainment, we can create deepfakes. I think you guys must have seen the news articles where there are many people who are actually making fake videos of the CEOs of the company and they are fooling their employees, right? So criminals are also using this deep fake. So that's why the governance aspect is very important here. Okay, so to generate realistic video, I think we have also seen in the one of the first slide, we can actually generate realistic video or the video games as well. We can do. So the technologies behind generative AI are mostly, they started with GANs, generative adversarial networks, and then VAs were also there for some time, and then now they are mostly transformer based. Like, so for example, there is a GPT, like chat GPT is based on GPT 3.5, GPT 4.0, and all those things. So all these large language models are based on some kind of transformer. Okay, any example you guys may want to say about like the technologies you know in generative AI? Okay, so you can write in the chat box, or maybe you can ask us the question at the end. Okay, so there are so many use cases are available in industry. We are heavily using it. I'm not sure how the academic world is using this, but for every application, like we are using like most of these tools. So, for example, let's say if I'm working on some text application, we have the Microsoft Copilot assistants, where whenever we actually have to write some summary, some paragraph, or some PPT we have to make, then we have Copilots, and these are actually helping us to generate the content, to translate or to make the emails, or to write the reports, right? We are actually using some kind of LLM, and we are doing our job in a few hours, which we actually usually spend in if spend days. Okay, so for example, to write the code as well, for code documentation, and to generate some code of say, very simple parts of the code. So basically, we are using some kind of LLM. And similarly, for image, speech, video, and 3D, also there are so many tools available. You can explore these, and I think you can also save your time. Okay, so the common Gen AI technologies are these. We have already seen. I will only give a gist of of these. So, for example, if I talk about generative adversarial networks, GANs actually consist of two neural networks, a generator and a discriminator, that works in opposition with each other. So if I give a real world example, so for example, let's say there is a bank which generates some real money, and the discriminator knows that, okay, which is the real money, which is the fake. Okay, so generator is actually a like you can say counterfeit. So he generates some fake currency, and he wants to make sure that he can fool the discriminator. If the discriminator says that, okay, it's a fake money, then it will actually modify the currency that is generated, and it will update its learning what is the real money, and then it will modify it. Okay, so when the discriminator stops recognizing that it's a fake money, it's a highly near to the real money, it's highly looks like the real money, then the generator's job is done, and it will say that, okay, so this is the real money. Okay, similarly, this is happening with the images as well. The generator actually tries to generate the images which are which looks like real images. Okay, so if the discriminator says that, okay, so this looks like a real image, so generator's job is done. Okay, so this is how the GANs actually works, how the training is done, and all those things is actually a very big part here. How the loss function of the generator and discriminator is coming. So we can talk offline, but this is the intuition I wanted to give. So basically, the goal here is for the generator to improve its output based on the feedback from the discriminator. Okay, so now there are large language models. These are AI models trained on vast amount of text data to understand and generate human-like language. So these are based on transformers. Okay, so basically transformers is actually a very common word. In our school days, we were actually studying about voltage transformer. And I think when you were fond of like movies, I think you also know about transformers in the movies, and in the LLMs in industry, we actually use the transformers which actually do the encoding and decoding, some kind of encoding and decoding. Okay, so this actually has two main mechanisms. One is the attention mechanism, which enables the model to focus on different parts of the input sequence. So basically how a particular word is important to the different words, and then it also supports parallel processing, which processes the entire input sequence simultaneously. So another type of Gen AI model is a diffusion model, which also known as denoising diffusion probabilistic model, DDPMs, and they actually generate the realistic images in two phases. One is the forward diffusion and another is the reverse diffusion. In the forward diffusion, what the model do is it starts from the original image and it starts adding the noise. And in the forward process, the reverse diffusion, what it tries to do is it tries to use uh, this noisy image and tries to generate the real image. Okay, so when something happens in the real world, what we do is we actually start with some kind of noise, and then we will generate an image from this noise. Okay, so this is how the diffusion models are actually working. And whenever you see some image generation based model, this is actually a diffusion model, and this is also highly accurate. So all the 3D image generation models, they are based on the transformers. Okay. Okay, so now let's just start with LLMs. I will give some overview of it, and then we'll start with the RAG and prompt engineering. In 2017, Google revolutionized text generation by coming up with a paper, Transformers. The paper title was "The Attention Is All You Need," and it was heavily based on the multi-head attention, self-attention. Okay, so which rapidly becomes the state of the art in most of the NLP problems. And nowadays, any LLM that you actually see, LLM or VLM, they are based on some kind of transform. Okay, so for example, OpenAI's GPT, Delhi, all are based on this transformers. Okay, so we have already seen this. Okay, so there are so many open source LLMs available. So if you actually want to use, basically Gemini is also, basically this is a proprietary LLM, but you can easily access it. But these are the LLMs which you can actually fine tune and train them for your own task. These are the proprietary LLM available for the business use. You have to pay to use them. Okay, so if you see the magnificence of LLM, so for example, if I talk about handwriting recognition in 2000, so this horizontal line actually says about the human performance. In 2000, most of the applications had like very low performance than the humans. But after the arrival of the transformers, all of them I have actually beaten the human performance, right? So they are now above the human performance and they are highly accurate. Okay, so that means these models are actually accurate than the human. So that's why the industry is actually seeing some disruption, and they actually want to use these models as compared to humans. Okay, so what are LLMs? I will actually give some example and then we'll go to the RAG. Okay, so these transformers are actually based on some encoder decoder architecture. So I hope you guys are aware about the vanilla RNNs. So this is a kind of vanilla RLL. Maybe you can assume that it's a fully connected layer, or this is an LSTM layer where there is an input layer. And let's say if we want to decode it, so what we will do is we will use the encoder to actually encode it in some latent representation, and then the decoder is actually used to decode it in some other sense. Let's say if you want to convert from English to French, so this is the kind of model that we generally use. Okay, then comes the transformer, which is actually based on this encoder and decoder architecture, but it actually is built or fully built on the self attention. Okay, so which is a point wise processing and attention. It doesn't contain any recurrent or convolution unit. Okay, so what is this model is this the actual model where there is one model which is the encoder and the second model is the decoder, and we give this input embeddings and the output embeddings for the training for the decoder, and it actually outputs the output probabilities of how one particular word is actually relevant for the whole sentence. Okay, so this is what generative so transformers is. It actually analyzes chunks of data which is called as tokens, and learns to predict the next token in the sequence. Okay, based on the previous tokens which are if they are available. So there are so many LLMs, the LLMs which are actually based on the transformers. So for the music, there is a music LM from the Google Jukebox from OpenAI. For image, there is ImageGen, Delhi, and so on, right? So there are so many transformers based models are available, which are actually generating highly real world looking content, whether it's an image, music, or text. Okay, so there are two parts of the transformer model. One is the encoder. The encoder is actually this, which contains two parts. One is the multi-head attention, and the another is the feed-forward layer. Okay, so feed-forward layer, you must be aware, like it's only the normal perceptron layer, which we generally use in the neural network, and the second is the multi-head attention layer, which is actually attending to the different other parts. I will say like what is multi-head attention in the coming slide. Okay, so there are 6 identical layers which are stacked with each other, and each layer is 512 dimensional, and so they are actually working with each other to generate the encoding of the input signals. And then there is a decoder which actually contains 3 parts. One is the mass multi-head attention, and second is a multi-head attention in the feed-forward layer, like the encoder. So this mass multi-head attention, what it do is it actually masks a few words in the input, and then it tries to predict the next word when this information is not available. Okay, so this is actually the advantage in the training, and the transformer actually generates a very high quality output. Okay, so this is a self-attention layer which actually contains 3 parts: value, key, and the query. So we actually ask a query like how important a particular word is to that sentence, and then so using the value of so basically key actually contains the different elements in the sentence, and the value contains the different the values of these elements. Okay, so then using this query, and from this v and k, we actually generate the attention scores, which actually says how much relevant a particular word is to the sentence. Okay, I will not go into the details of the calculation. We can discuss it offline if you want. Okay, so this is how the architecture is coming up for the multi-head attention, where we have 3 components, and this is how the things are actually coming up as the output. So there are several of them. Okay, so there is not only one attention node, but there are several of them, so that we can actually ask several questions. We can have several queries that can be answered. Okay, so I think there are like if you actually want to try these LLMs, and if you know it, I think I'm giving you one particular question. How would you determine if the sentiment in the news article about a company indicates a positive outlook for buying its shares? So for example, nowadays you must be hearing the news of Byju's, right? So they are actually facing a lot of backlash, right? Can you suggest about like, let's say it's not actually listed in the share market, but like let's say if such a company is listed in the share market, what will you actually do to its shares, right? Can we actually use BERT for this particular task? Okay, think on it. If you have any queries, you can ask me. I will be very happy to answer. Okay, so I think these were the technicalities, like some introduction about all the things. Now, how is it that we can use these LLMs for our own task? Okay, so there are 2 things here. One is the RAG, and another is the prompt engineering. Let me start with the RAG. Okay, so RAG is a powerful technique for enhancing LLMs by feeding them with relevant information from the external sources. So, for example, with the chat GPT, right, you can ask several questions, right? It will answer you them. But let's say if you ask about the admission process of your college, it may not have the information, right? Because it is not trained on that particular data. Okay, so how is it that we can actually create a chatbot using ChatGPT, and we don't have to train it as well? Okay, so this RAG is a very powerful technique by which we can actually give this context information to the LLMs, and we can actually build something on it. Okay. Okay, so this RAG is actually highly useful to actually give domain-specific knowledge to the chatbot. So, as example, I have just given, and it actually improves the accuracy of the LLM. So, for example, let's say if you ask about your college, canteen, right? It may not have some information, but like the accuracy will be very low. But let's say if you use RAG, the accuracy will come up. Okay, so it combats hallucination, it builds trust among the users of the chatbot, and so on. Okay, so now this is the architecture of RAG, where let's say this is the some knowledge base of your college, you create some context vectors out of it, and then this is that, let's say, ChatGPT is LLM. So the LLM actually gets this context vectors. Now a user actually asks a query like what is the admission process of your university, then it actually uses the context information here and then it generates the response. Okay, so basically it's the right use of information retrieval, and it actually helps to create a chatbot which is highly accurate. Okay, so this knowledge assistant with basic RAG that we have seen is highly primitive. With naive data processing, it's actually like highly basic. It has poor query understanding, non-functional calling or tool use, and it's stateless. It has no memory. Okay, so how is it that we can actually improve? Okay, I will just tell you that. So now there are three ways to create a better knowledge assistant. One is advanced data and retrieval modules. Let's say, for example, this is the data, this is not date, this is the data. We do some text splitting, we do some indexing, and we can actually, from the query, right, we can actually extract off 5 question answer prompts, and then we can actually show these 5 to the user. And this is actually highly better than only generating one specific response, which may be inaccurate. Okay, so another is like agent based. So now I'm starting with the agent's definition. So I think like you just see it. If you guys don't understand, ask me the question. When we will talk about agentic AI, I think that will be very clear. Okay, so now let's say if we create with a single agent, right? So the advanced RAG pipeline that we used in the previous approach, we'll use that. And then there is an agent. It has some capabilities like it can use some tool, like so for example, web search, or maybe using your Gmail or the calendar. It has some memory. It knows about like what you were asking about the past. It has some reflection. It can refine itself, and it has some query planning. Okay, so it has all this capability. I will be talking about these four very soon. Okay, and then based on that we generate the response. This is one agent. Okay, another is like we can actually create several agents. This is called as agentic AI, a framework kind of thing, where there are multiple agents are working to create to solve a particular task. So we have a task. So then there is one agent which is actually acting as a orchestrator, and then another is like having some knowledge base, and then it is retrieving some information. And one particular agent is actually seeing some SQL based queries to extract some that information. It combines the extracted information, and then there is a another agent which is like refining the output, and it then generates the response. So this actually is more better than the previous variants. Okay, so this particular approach where we are actually using agents to actually generate the response from the tools, it is also called as agentic RAG. Okay, so these were the details of RAG. Now let us see about prompt engineering. I think now you will start enjoying the lecture. So I would request you to be attentive here because now I'm talking about the stuff which is actually highly relevant for the industry, and you guys can also see it. There is no coding. By only using some prompts or basic English queries, you can generate great response. Okay, so if you want to see some prompt engineering guide, you can go to these links. There is a very good paper, Chain of Thought. You can go to this link, and they actually say that how is it that you can generate highly accurate results from the LLMs. Okay, there are other papers as well, like so for example, Tree of Thought, Graph of Thought, and so on. Okay, so what is prompt engineering? Is basically actually improving the output with actions like phrasing, queries, specifying styles, providing context, and assigning roles, and so on. Right. So this is what like a particular query is. Let's say like so there was a math problem where we don't use any chain of thought. The accuracy is very low. But let's say if we use chain of thought kind of prompting, the accuracy shoots up like at a very good rate. Okay, so what is chain of thought? Basically, popular technique consisting in guiding LLMs to produce a sequence of intermediate steps before giving the final answer. So we'll see how the chain of thought is actually coming into existence. Okay, so there are so many things that we can do using ChatGPT. So one is like, so for example, we can do essay writing by only specifying some details. We'll see how you can specify those details and you can generate the whole essay. There could be a possibility that it is not highly accurate. So we can, how is it that we can modify our prompts to generate a very accurate, very accurate essay. Another is summarization, where we have a big text and we actually give a prompt to summarize the content here. We can do some language translation. We can actually do some information retrieval. So, for example, let's say if we have some financial documents, if you want to retrieve the assets and liabilities of a particular company from a, let's say, 100-page document, we can use some LLM and it will retrieve that kind of information in a few seconds. Invoking API calls and actions. So we can also use these LLMs or chatbots to actually do some action calls. Okay, we'll see how this can be done. Okay, so now let's just see like what is prompt engineering. Okay, so the prompts involve instructions or context passed to a language model to achieve a desired task. Okay, so prompt engineering is the practice of developing and optimizing the prompts to efficiently use language models. Okay, so we'll see. I think the definition is very clear. Prompt is just a query, and prompt engineering is actually is the practice by which we can develop efficient or optimal prompts. Okay. Okay, so the one of the basic prompt is, let's say, for example, the sky is. I actually want to complete this particular sentence. The answer is blue. Okay, or maybe the response could be the sky is a beautiful blue color during the day. The blue of the sky is this and also right. So this response is actually generated by the LLM ChatGPT, and ChatGPT's model was Text DaVinci 003, and these were a few parameters that we can specify. Okay, so the elements of a prompt are the following. Okay, so it contains four things. One is the instruction, context, input data, and the output indicator. So, for example, let's say if I'm saying classify the text into neutral, negative, or positive. So the command that we are giving is actually called as the instruction. Okay, so we can give the input data, the text. So we are giving this instruction to work on this particular text. I think the food was okay. Okay, and then there will be an output indicator which the LLM will actually generate, and then there is some context which we can specify. So for example, to use the RAG, we can also specify that. Nowadays you can specify images PDF to the chat GPT as well, or you can create your own chatbot by using LangChain. Okay, so now let's just see about prompt engineering. There are three ways by which you can use prompt engineering. One is zero shot prompting. So that means you give no example to the LLM. You just directly throw up the query, and you will get the response. One shot prompting is when one example is provided. Few shot prompting is when a few examples are provided, typically 3 to 6. Okay. So, for example, let's say this is what we have given to the LLM. So, we have given a tweet to the Lufthansa, please find our missing luggage. The sentiment is negative because something, the luggage is missed by the airline. So, now another example we have given is will be on LH to Frankfurt very soon. Cheers. So, the sentiment is positive. Now we are asking so we have given two examples, and third we have given a tweet, refuse to compensate me for 2 days cancelled flight of an airline. So then we want a sentiment from the LLM. So then now the LLM's response is the negative, and we have actually not given any instruction. We have only given a few examples. From these examples, the LLM has actually understand that okay, so we have to predict the sentiment of it. This and it has predicted that the sentiment is negative. Okay, example of an input and output of two-shot prompt. Okay, so we have given two examples. So it's a two-shot prompt. Okay, now let's just see how is it that we can actually do text summarization using uh, ChatGPT or ChatGPT only. Like we will see. Okay, so let's say we have given some context, and then we will give the instruction. Explain the above in one sentence. We can say that above in 2, 3 sentence, 4 sentence, whatever, right? So then the output is coming. So this is how we can actually do the simple summarization using ChatGPT. Okay, so now question and answer. Let's say what we have said here is answer the question based on the context below. Keep the answer short and concise. Respond and sure about the answer. If you are not sure about the answer. So we have given the context, and then we have asked the question, what was OKT3 originally sourced from? So we have said that, okay, you have to answer the question from the context. So we have specified the context, and then this is the question. Okay, so then the ChatGPT's answer is mice. Okay, so this is how you can actually make ChatGPT work for question and answering. So this is how we can design efficient prompts. We can actually modify a few of these parts to actually come up with the question and answer. Okay, so now to do the classification, we'll say that, okay, classify the text into neutral, negative, positive, the text we have specified, and the classification result is coming by the ChatGPT itself. Okay, we have not trained any model, only we are specifying the instructions. This is called as prompt engineering, and the sentiment is coming as a output. Okay, so now what are the few prompt engineering techniques? So one is few short prompting, we have already seen. Chain of thought we will now see. There are other methods as well, like self-consistency, knowledge generation prompting, and React. We will skip these, but I will show you about chain of thought. Now let's just see, right? A few short prompting example. Let's just see. Okay, so the odd number in this group add up to an even number. So the answer is false. One example we have given, another example we have given, third example, fourth example. We have given 4 examples, and then now we are saying that the odd number in this group add up to an even number. We have given a few numbers. The answer is true. Okay. So now let's just say we'll use chain of thought here. Okay, so just see, right, in this particular example the answer is said to be true. Okay, but which is incorrect. Now let's just see, we actually want to improve. The answer is actually false here. How is it that we can improve ChatGPT's response using chain of thought? So what is chain of thought? It's actually sequence of prompts by which we can actually see how the response is coming up. So we will combine this with one short prompting. So one short prompting, what we have done is the odd number in this group add up to an even number. This example we have given. So what we have done is we have given some sequence of prompts, adding all the odd numbers, which are 9, 15, and 1. We have extracted the odd numbers. The answer is 25, and the answer is false, which means it is not group are. So what it says is adding all the odd numbers, we have extracted the odd numbers, it gives the 41. Is it the even number? No, the answer is false. Earlier it was saying that the answer is true, but now it says that the answer is false. So that means by actually modifying your prompts or the sequence of prompts by using chain of thought, you can actually improve the response that you are getting from the ChatGPT. Okay, so the math kind of problems also can be improved, can be made more accurate by using these kind of techniques. Okay, so let's say another example with zero shot prompting. Okay, so I went to the market, bought 10 apples, I gave 2 apples to the neighbor, 2 to the repairman. I then went and bought 5 more apples and ate one. How many apples did I remain? The answer, it says that 11 apples you have, which is inaccurate. Now, how is it that we can improve it? Let's say we can say that we can use zero shot prompting, but we will specify one particular instruction. We have specified that. Let's think step by step. Okay, so then now ChatGPT will give step by step answer like what we do in the chain of thought. Okay, it is identifying all the step, and then it says that finally you ate one, so you are left with 10 apples. Earlier it was saying 11 apples. Now the answer is correct when we specified more information. So this is how you can actually make your LLMs more accurate, or your chatbot more accurate, by using this prompt engineering and RAG techniques. Okay, so now we will move to the agentic AI. I will not take much of your time. I will like say how we are actually using this prompt engineering RAG in our real world use cases in industry. Okay, so just see about digital human, right? We are in the era of co-pilots, assistants, agents, and beyond. So we are actually creating digital humans which mimic human communications as they offer a range of service. So for example, sales agent, sales assistant, social media influencer. There is a social media influencer which already has 2.7 million followers, and it is actually generating an image of its own by in different poses, different locations, and so on, and people are actually liking it. Okay, so there is no human doing it, it is done automatically. So this LLM actually creates one post every day, and everything is happening on its own. no one is actually working. So there is a like giving like an impression of the digital human. Okay, so this is, I'm not sure like if there is any use of this particular thing, but the industry is actually like leveraging this particular concept heavily to create digital human. For example, for four kind of digital humans can be actually made based on the personal relationship, business relationship, the focused experience, and the task focused. Okay, so for example, virtual assistants we can make. So for example, rehabilitation therapies, personal assistant, career coach kind of thing we can make. Virtual companion, like for example, elderly care, virtual influencer, like so this particular example. Virtual agent we can make. So for example, digital patient, call center agent, digital instructor we can make, sales agent we can make. So all these virtual agents can be made by by leveraging the agents that we are creating. Okay, and how we can create the agents, I will be saying, I have said a few examples earlier, and now I will be specifying all these things that we are actually using. Okay, so now I think most of you are aware about Microsoft Copilot, which is actually AI-powered assistance in the Microsoft 365 applications, where you can actually create documents, you can analyze the data and do the communication, right? So like what typically you do in ChatGPT is integrated in the Microsoft Word, Microsoft PowerPoint, Excel, and so on. Okay, so now we are moving from co-pilots to agents. So the co-pilots are actually more collaborative and assistants, but agents are more autonomous, and they are actually taking actions on their own. The capabilities is that they generate suggestions, they translate languages, they answer complex questions. But the capabilities of our agent that they make their own decisions, they perform some tasks, they adapt to the situations and interact with the environment. So now they are the human itself, right? So human is actually doing all these things. The capabilities of human are actually coded into the agents. So the kind of decision making that Copilot make is they are more suggestive. They provide options and insights, but they doesn't make their final decision. Okay, so the decision making that agents are doing, they are more independent. They are learning from the data and the algorithms, and they are doing everything on their own. Okay, so I think, are we still there on the call? Okay, yeah. So basically agents are more independent. They are making their own decisions. They are doing all the things there on their own. Okay, so the agents is basically is an autonomous entity that observes its environment and takes actions to achieve specific goals. So the type of agents we have is a simple agent, complex agent. They all are like actually made to solve simple tasks or some sophisticated tasks. So basically all of them, all of the agents are mostly LLM based agents, where we are utilizing LLMs to process and generate human like text, enabling advanced natural language understanding and interactions. Okay, so these are the agents that are actually uh, we are having. So now, like what are the enterprise use cases? So for example, document processing, tagging, and extraction. So for example, we have a document, we can actually like generate summary, we can do some tagging, we can do some like data extraction from it. So knowledge search and question answering using RAG. So we have a knowledge base, we can do some question answering, we can identify the sources and all those things. Okay, conversational agents are there. There is a human, it will do the conversation with some human. And then workflow automation, the thing that we will be now talking about. So for example, there is an email, we'll have a workflow, we read the latest messages from a user A, we send the email, we do all the things, we write the email, we'll basically everything is done by the agent. Okay, so all the responses. So for example, let's say if you are a sales agent, or maybe let's say if you are on a, you're checking the emails and you have to respond to the user queries, it can be done automatically. Okay, we'll see so how these things are actually happening. So what is agentic workflow? Now a non-agentic workflow is like, so kind of zero shot prompting we are doing in the agents. So the kind of prompting we will do, please write out an essay on topic X from start to finish in one go without using backspace. Okay, from start to finish, it will generate the essay. Okay, nothing, I think it will be inaccurate as well. Okay, so this is how non-agentic workflow is coming. Now there is agentic workflow. So what we will say is we will modify our prompts, write an essay on topic X, Do you need to do any web search? If let's say if you are writing an essay on something which actually doesn't know about, it will do the web search. It will write the first draft and then consider what parts need revision or do research, revise your draft. So basically you will write the essay, you think, you will research, you will do web search, and then you will write again, you will revise it, and then so on. You will repeat it until your draft is final. So this kind of approach is more accurate as compared to the this basic approach that we actually use in this non-agentic workflow. So this is agentic workflow on which we are training an agent to refine itself and to improve the task at hand. It will make its own decision. Okay, so let me give you an example. So for example, let's say digital health assistant. There is a cardiologist which actually has a patient and he has a long history. Let's say the patient is 25 years old, and or let's say it's a 16-year-old patient, but he has a history from since birth. Okay, so 16 years of medical history. It's very difficult to actually get all the reports. And let's say if there is a new cardiologist, so let's say give me the clinical summary and interval change which have occurred since last clinical visit. Okay, so there is a digital assistant based agent which is doing all the stuff on its own. So it will extract the required information and then it will respond to the cardiologist. 16-year-old with pathology of fallet repaired at 3 months age, has a severe right ventricle enlargement. Last clinical visit in 2023, recently seen in ER and so on. All medical terminologies. Okay, so when was the last Holter and stress test done? So last Holter was in 2023 due to palpitations, and Holter was showed rare PVCs and so on. Okay, so and sure, that would help. Okay, so by the way, do you need the cardiac MRI results from the last year? So this agent that we have created is highly accurate, and it is actually like working in sync with the cardiologist and helping the cardiologist to do all the things. So that means the manual work, which was highly tedious and maybe inaccurate and maybe time consuming, so the digital assistant is actually doing it at a very faster pace, more accurately, and at no cost. Okay, so these digital assistants are actually helping to create the value. So for example, they are not only assistive and automotive, they enhance digital experience, they are adherence, and they increase engagement. They are more intelligent, they are embodied in nature, they are customized, they are proactive, and they also create the brand loyalty because they are more accurate and we can trust them. Okay, so now let's just see about agentic workflow. A few examples I would like to give before I finish. Okay, so there are the agentic AI design patterns are the following. There are four things we can actually do. One is the reflection, tool use, planning, and multi-agent collaboration. So what is, okay, so these are actually proposed in the recent research papers, and these are the research papers. If you actually want to get all the details, I will be actually giving only a few details of these. Okay, so one is the reflection, which actually means self-refine, where let's say there is an LLM based agent, we actually give a query to the LLM. Okay, we get the feedback, we got the result, but we'll also make the agent refine itself by giving a few prompts of it on. So okay, so for example, let's say there is a coder agent, please write a code for task this. Here is a code, and then there is another prompt for the refinement of it. Check the code carefully for correctness, style, and efficiency, and give constructive criticism. Okay, it will check on its own. There is a bug on line 5, please fix it. It will create the version 2. Okay, it failed the unit test 3, try changing it. It generates the next version. And this is the coder agent, right? So on its own, it is generating the response, it is refining its response, and so on. Okay, so this is the efficacy of it. Now you don't have to write the code. There are agents coming to write the code. Okay, so now reflection with multiple agents. So the things that were actually doing the refinement can be done by the another agent. So there is a critic agent and there is a coder agent. Coder agent is actually trained in a way that it is more accurate in the coding. Critic agent is actually more like accurate in terms of the test cases that it is analyzing. So it's good to have two agents. It will only see like how the things are actually coming up. They will talk to each other and they will refine the output the way that happened in the previous slide. Okay, so this was the reflection. And another is a tool use. Tool means like, so basically we can actually like make these agents use a tool. So for example, web search. So for example, let's say if you want to identify the best coffee maker according to the reviews. So the OpenAI Copilot, what it will do is it will make use of the web to identify the best coffee maker according to the reviews. Okay, so this is how the output will actually come. Okay, so you can make LLMs use, or the LLM based agents use these tools. Like, so for example, for code execution, Wolfram Alpha for math applications, and code interpreter can also be used. Search engine can be used, Wikipedia can be used, email calendar, and other image based tools can also be used by using these agents. Okay, so these are actually highly helpful. So whatever tasks that you were doing manually can now be done automatically using agents. So this is highly fascinating. Query planning. Okay, so now what we want is we want the LLM to generate an image where a girl is reading a book and her pose is the same as the boy in the image example.jpg, and then please describe the new image with your voice. We want it to do all these things. Okay, so this is the image example.image. We want to like do a few steps. Now on its own it is planning everything. First, the agent will actually determine the pose by using a tool, open pose model, and then this is the pose that is coming as the output. Okay, now pose to image conversion by using Google VIT model. So it has actually generated a girl's image in the same pose who is reading a book. Now it won't actually want the description of the image. So image to text, a girl is sitting on a bed reading a book. Now it also wants it to pronounce, then using some speech text to speech model, it will actually do the pronunciation. So just see, right, how efficient this is. The LLM on its own doing all the things. We are creating an agent which can use different tools and which can do the query planning. And this is how efficient the result is actually coming. Another potential design pattern is the multi-agent based collaboration. So for example, let's say if there is a hackathon going on, and then what we actually want is we want a few agents to do the testing, few agents to do the documentation, few to do the coding, few to do the designing, and so on. Right? All the agents are working with each other to do some tasks. So for example, let's say if we use, if you want to generate biographies, a single agent has an accuracy of 66%, but multiple agents will give you an accuracy of 73.8. In the chess, a single agent will have an accuracy of 29.3%, but multiple agents will have 45.2%. Okay, so this is like the efficacy of using agentic architecture. They are actually, these LLM based agents are helping to automate the workflows, which is actually called as agentic workflow when we are using autonomous agents to do the task. Okay, there are several other examples of the workflow automation or the agentic workflow automation. So, for example, multi-agent debate can be generated using these agents. Multi-agent code writing. One agent will do the code writing, one will review it, one will test it, and so on. Okay, so there are several companies which are coming to create these calling agents. So, for example, they will call each other, and let's say, for example, like these call center agents, right? They are now coming, and for one person there will be one agent. You actually don't have to wait for the call. Okay. Automating routine tasks. So, for example, drafting your emails, generating reports, managing data entry, you can do using agentic workflow automation, personalization to improve the output based on individual preferences, scaling operations, the manual operations that you were doing, like you can use these agents to like increase the capacity. Automating HR workflows. So, for example, automating job posts, identify resume relevancy, and so on. You can actually do it. So, most of them we are using it in our work, and we are helping companies to do the workflow automation. And we have created one tool for HR workflow automation, another for the finance. Document analysis tool by which actually helps the traders or the banks to actually analyze the financial statements of a company. Okay. Another is this like, let's say, like I will leave you with this particular example where, let's say, we are actually giving one query and the LLM on its own is doing all the things based on the pose of example one.img, the example, the pose of the person in this example and the description of the example to please generate a new one. So the description of this particular image is a boy is riding a cycle. Okay, so we have to use the pose of this thing. So this pose and the boy is riding a bicycle. Okay, so just see, right? By only using one query and two images as the input, the whole response is generated by the LLM or the agent, we can say. Okay, so this is the like the queries that it has planned. It has to do some task which is pose detection, image to text, and image to so pose text to image, and so on, right? All the things are actually done by the LLM itself. Okay, so this is see, right, how accurate these agents are. And I think this is the time to actually learn how to code these agents. How is it that you can actually create your own agents, and how you can start with the agentic workflow automation, because this is going to be the future. And I think that to the teachers available here in the talk, I request your students to start with these agentic workflow, agentic AI, so that they can be trained for the skills that we require in the industry. Okay, so to conclude my talk, the set of tasks that AI can do will expand dramatically because of the agentic workflows. We have to get used to delegating tasks to AI agents and patiently wait for a response. Okay, so you don't have to do the manual tasks that you nowadays do. First, token generation is important. Generating more tokens even from a lower quality LLM can give you good results. So, for example, let's say if you are using GPT-5, you are waiting for GPT-5 or Cloud 4, Gemini 2.0. Instead of that, you can use this agentic reasoning with the lower models, and you will get more accurate results. Okay, so this is like the conclusion of my talk, and thank you for attending the talk. So if you want to connect with me, you can connect on this number or this email ID, and I'm happy to take questions now. Are there any questions?
Hello, sir.
Yes, please.
So I have this doubt about this agentic workflows. So, what can I see it as a what real problems does it solve in this current IT landscape, sir? So, what are the commercialized problems that we could find using agentic workflows?
So basically, all the application that I showed you, right, are the real ones. Basically, just to show the design patterns, I have actually like showed you the screenshot of the of a research paper. What we are currently, I think not currently, but we have already developed tools for HR workflow automation, for finance, like so for basically. Like analyzing the financial documents of a company for the regulators, for the auditors, for the banks, and for the traders. Like how is it that you can actually analyze how a company's financials are coming up, whether they are good or not, right? So there are several agents coming up to actually do those tasks. Another workflow automation that we have done is for the policy generation. How is it that you can write a policy document? Like, so for example, for government policies, there are several other policies in existence. How can you use the previous policies to generate a new policy, right? Another example is like, so what we are generating is for like, so how is it that you can actually like help a student clarify its doubts, right? So we are currently working on that. So it actually requires different agents to be to actually understand the students needs, to understand like what are the relevant concepts and all those things, right? So these are the real world applications. Agentic like workflows are actually like, I think most of them are deployed in the real world as well. So for example, the when you call to a customer care, right? I think nowadays most of the companies are actually talking in the natural language. Okay, so there is a robot talking. So that is the right implementation of the agentic workflow. So I hope I have answered your question.
Yes, yes, yes. It's good. Thank you, sir. Thank you so much.
Yeah. Any other question?
Thank you, sir, for sharing your insights and knowledge. Acknowledging the good that you already have in your life is the foundation for all abundance. Gratitude is the key to abundance. I would like to call Dr. P. Nagraj, sir, Associate Professor in CSE and faculty sponsor of our Career ACM software, to extend our gratitude for delivering the vote of thanks and acknowledging the collective efforts that make this industry expert webinar possible. Nagraj, sir, please, sir.
Yeah, yes, Vidya. Good evening, all. Good evening, everyone. Good evening, Dr. Anil Sharma, sir.
Good evening, sir.
Actually, sorry for the inconvenience. 6 o'clock, I'm in traveling. That's what Dean Ma'am was joined
Okay.
and welcome you. Yeah,
No
fine.
issues. Yeah, that's
Yes,
fine.
fine. Thank you so much. On behalf of Kalasalingam Academy of Research and Education, and we have the chapters, Career ACM student chapter. It is my great pleasure to extend my heartfelt thanks to you, sir, for leading today's insightful webinar on Cognitive Workflow and Generative AI. Really, I have attended the full day of full section of the webinar. Your expertise and vision in the field of generative AI have truly enlightened us, and we are deeply grateful for the time and effort you have invested in sharing your knowledge. Thank you once again, Dr. Sharma, for accepting our invitation, for your enlightful presentation, and for being such an inspiring role model for us in terms of how the developing generative AI and LLM model to the real world applications. We look forward to more such engaging section in the future also. Thank you. Thank you so much, Dr. Sharma.
Thank you, Professor, for inviting me here.
Yeah, thank you, sir. Finally, I would like to thank all the participants, students, and faculties for your active involvement and keen interest in terms of cognitive AI and generative AI. Your presence had made this webinar a grand success. Thank you, one and all, and have a great evening.
Thank you, sir. Thank you to everyone for joining us today and making this webinar success. And now you may leave the session. Thank you, guys.
Yeah, thank you, guys. You may leave. Thank you, Dr. Anil Sharma, sir. We will communicate further for the further collaboration and fostering.
Sure, I can leave, right?
Yeah, sure, sir. Thank you so much. Yeah, Lokesh, you can end the meeting.
Okay, sir.
Yeah, thank you, guys.